Hey guys, what's up? What's crack-a-lackin'? Hope everybody's having a good day today. Just going to come on here. This is going to be a very short one. I'm going to go straight through the information, guys, and make sure you guys. Hey, Joanna, good to see you, girl. Been a minute. Glad you're here. Pam, what's up? Trish, hey. Hey, Judith. Hey, guys. Crazy Granny. Love the name. Love the name. All right, guys. I'll check on the chat after I'm done going through all this stuff real quick. But remember, guys, Adam is live right now too over on Marfugal. You're not going to hurt my feelings at all if you go over there and watch him and come back and watch me on a replay. Okay. I don't like going live when people that I like to watch myself. And, obviously we try to help each other out and not be live at the same time. But when you got a lot of good people around you, sometimes there's just not enough time slots. You know what I mean? But I just wanted to come on here because we do have a geomagnetic storm warning. They did update this after my video last night. Okay? And so what we're doing here, Bob Anna. That's a pretty cool name. My guess is that's probably a combination of what? Two names? Bob and Anna. Probably a husband and a wife. Or a wife and a husband. Whoever. I don't know. Anyway, cool name though. Alright, so I am going to put the chat away, guys. I'm going to definitely do that. I can't look at it. I squirrel off. I like talking to you guys too much. But, anyway, if something happens while I'm doing this, guys, just shoot it at me, okay? And just tell me, hey, maybe we got something going on, right? Alright, guys. Anyway, sorry about that. So we got this geomagnetic storm coming, okay? We were in it yesterday for 6 hours. Now, this is coming from that bigger eruption I showed you guys. And as things start to uptick here, they're starting to now, okay? The solar wind speed's actually starting to pick up. As you can see, they're now predicting or forecasting a G2. It's very similar to what I said last night that I thought was going to happen. And so we're just going to do that, right? I mean, that's just what happened there. I think I got this one kind of right, at least the way that all the forecasting is coming out right now. But I'm not saying that because right. I'm just saying that this is just one of those things that helps us, confirm each other is what I'm trying to say. So I do think this is coming. I do think it should be here very shortly. This thing is moving pretty fast. I showed you guys that. I think it's going to get here in less than 3 days. And you guys know that most of the time, they take between an average, I would say 3 to 5 days for a CME to get here. But this one seems to be moving a little faster, okay? And there were other CMEs in front of it, which is compounding things. And there's a whole lot of stuff going on with that. And so many variables here that are in play that could change things in a drastic way just by one of them moving a little bit. We've also had some more eruptions today, guys. So this is not going to slow down. Like I said, I think a lot of us have been saying that now for a very long time. This is starting to get to the point where we are going to be dealing with this stuff on the daily. And that's kind of what we're seeing. Let me pull up the Discover data. I forgot to do that. We will take a look at that just real quick. This is the data points that we look at here. This is what we look at if we're going to try to see what kind of real data we've got coming in and the conditions that we have currently, right? So, anyway, what you're looking at here, we look for -6 on the BZ. That's the red line here at the top. And I'm not going to go into too much detail tonight, but essentially that's the angle, basically, of our magnetic field, if you look at it in that perspective. And it moves north-south. I mean, it moves a lot, is what I'm trying to say. So -6 is kind of the threshold we look for, right? And as I move this across, you can see that box kind of changing numbers. And when it hits -6, it'll turn it purple here on this graph. As you can see, we're kind of bouncing around. Things are kind of fluid right now. They're moving around. One thing I've noticed here in the past couple hours is the wind speed has dropped. The density's kind of staying pretty steady, but the phi angle, you can see a consistent wind. Okay, that's the polarity of the solar wind itself. Remember, guys, that the solar wind is charged, so it has a negative and a positive. So when that flips, just like a pole flip, but we're talking about solar wind here. It goes bam, bam. It flips back and forth, and when it does that, it'll give us geomagnetic jerks. It'll jerk us, and that it can intensify stuff. We've seen the phi angle actually yank on us hard enough that it put us into a very brief, like G2 storm. I think it's even did that and got us into like a G3 for a very short amount of time, right? But that is what it is. Hey, Leisure. Hey, Miss V. Good to see you guys. Hey, Hilly, I want to say hi to you too. I forgot to say hi to you a second ago. Okay, so back to this. So you guys can see that. That's what we look for. And it doesn't have to get to -6 to get hits. But the fact of the matter is, the stuff gets in easier, and that's why they show that here. Hey, Flamin'. Good to see you, brother. But, so, let's take a look at this, because they updated this one too, guys. Okay? This is the model I showed you guys yesterday. And I made a short little video for Marv too over there, and I think it came out pretty well. When I do it like that over there, it's kind of like me doing the show here, but I try to abbreviate it a little bit. That way, because I don't want to take it anything more than 5 to 10 minutes to give them an update. It's just not necessary. I don't think they would want me to do that anyway. It's a call-in show, so I'm out here talking all the time, and I just would prefer everybody else to call in and get their chance to do so, right? Oh, you got a terrible connection. Sorry, Hilly. That does suck, man. I hate that when that's happening. Hey, Daniel, what's up, bud? John, what's happening? But, yeah, guys, you can see this. This is definitely you can see when it popped off. And this is the NOAA version of it. I'm not going to show you the NASA version because it updated for another eruption, and it doesn't show this one anymore. I know where I can show it to you, though. Hold on a second. Let me find it. Not there. There. Not there. Okay, here. Alright, this is spaceweather.com. Go give them some love, guys. I mean, they rock it. You guys know I say that every video, but they do. Dr. Phillips over here he does a really good job with this. And, after I came out my video yesterday, it was kind of nice to look around the other sites and what everybody else was reporting. And to see a lot of us actually agreeing with each other. That's a nice thing to happen. And that's kind of what's going on here. G1 to G2 to G3. Right? They're basically saying the same thing I told you guys yesterday. And again, I'm not saying that to say, hey, oh, look at me, I was right. No, it ain't like that. I'm saying it because it just helps me build a little confidence in myself. And it lets you guys know that there's other people out there that are actually agreeing. So we just confirm each other. And that's why I say it. But this is the NASA version of that same model, guys. And this is the one I showed you guys yesterday. So if you kind of compare the two, this is NASA here. This is NOAA. So they're very similar, but they're not the same. This is a good way for me to show you guys that. So why is it different? Well, because number one, they're two different agencies. Number two, they use different data points, and they take like certain data entries. The model will take certain ones more serious than other data points, so it kind of changes things. It's very much like a hurricane model. When you guys look at like a hurricane coming in, get ready to crash in, what do you see? You see a bunch of different spaghetti string models, right? Why is that? Well, those are tons and tons of different models that take different data points and input it into the model at different levels. So that's why they don't always agree. And that's why they give you a cone, right? They give you a cone of where this hurricane is going to be coming in at. And there's more reliable models. They kind of know which ones to go to with that. But this is very similar to what I'm talking about here. So this would be one spaghetti string model, right? And then I guess this would be the other. Okay, so but they're both are green. That's what I'm trying to say. So over here, this one, I'll bring you guys back to this in just a second. I need to update these anyway, real quick. I just want to make sure that they're giving us the latest data inputs here. I'm going to take you guys over here to seeds real quick and show you the eruptions that's happening today. And guys, when you pop over here, if you guys ever go to seeds, and as a matter of fact, I'm putting this in the chat real quick. That way, if you guys want to go check it out, please do. Go play around with it. You can't mess nothing up. Okay, guys? Hey, Merc Dog, what's up, bud? Good to see you, man. But, yeah. So, there's that link. I think did it go in? Or did I? Did that post or not? I don't think it did it? Okay, here. There it went. All right. That's seeds. So, just come over here and you'll get to see both these satellites. But if you come over here and you see this, what is this down here? Well, when it detects a CME, right? When you see the blue, here I'll show you the blue lines, blue and red lines. See, when it gets these blue and red lines, that's when it's detecting something. You see this? It tries to outline it, see how big it is, all the above, right? So when it detects something and it's significant enough, this site actually will put it down here and give you like 10 frames, like right here. I'll click on this one. See what this is doing? It takes you right to the CME. It points it out for you. So, and something else here that's pretty cool. Sometimes I'll come over here and there'll be no data for like a day. But if I go down here, it's there. And it's just a technical issue on their end, but the data is there. A lot of people miss that. So when everybody's screaming no data, though, sky's falling because of no data, they might want to look a little harder before they start screaming that. You know what I mean? When you get 2 or 3 satellites, different agencies and stuff where they're missing data all at the same time, yeah, that's pretty sketch, right? I mean, you got to kind of look at that. You got to be a little skeptical when it comes to that. But if you can find the data that they use here on a different site, they're not trying to hide it. It's there. You can find it. As a matter of fact, I've shown you guys all how to do that. And it's not that hard to do. It's a simple Google search, to be honest. Now, whether you trust the data or whatever, that's on you, right? But the data's there to look at, is what I'm trying to say. But anyway, so let's take a look at today. And you're going to notice about 4 eruptions. 2 of them, I think one, maybe 2 went off the backside, and I think 1 or 2 came our way. So let me show you what I'm talking about here. Now, this is pretty typical too. I'm going to back that up. You see how, let's get it to there. See how grainy that is? Hey, Jan, what's up? ACR. See how grainy this picture is? This capture here? As I go forward, watch what happens. You see how smooth that got? That's because that's what this coronagraph is supposed to do. It will, basically it's increasing the definition so you can see this better. And it's doing that by just kind of concentrating on that. That's just what these things are, set up to do. But I want to point something out. You probably wouldn't have seen this if this was on the grainy part. Can you guys see that right there? See what I'm doing with my cursor here? That's a halo. It's very, very faint, but that's a halo from an eruption. So is it going off the backside or is it coming at us? Obviously, that's that's the question we always ask. And let me back this up a little bit so you can see that halo kind of take shape. You can kind of see it poke out here a little bit. Watch. See that? And I'll go forward a little bit more. You see how it's just going out now? Now, they call it a halo because it just pokes out around this occulter disk and it looks like a halo. That's why they call it that. It is no scientific anything with a halo. But as you can tell here, there's another eruption. And and again, now we got another halo over here. So we've got, I believe, especially this one here. You see how wide that got really, really quick? I think this one may actually be coming our direction. So not only we're going to get this stuff coming right now, we got other stuff coming. And we'll be talking about that more in depth, probably tomorrow. But let's look at the side. This is our side view, and I want to pause it. Now that kind of confirms that first one I said I thought was going off the backside, because we're looking at the sun from the side now. Earth is over here in this direction. Okay? Now the other satellite we were just looking at was from our perspective. So now if I go forward here, you see that? Now I know it doesn't look all that bright, but let me tell you something. It doesn't have to look bright to be intense. Okay? That's just showing you that this is actually going this direction. Right? It could be going like straight across from the satellite here, or it could be more at a right angle back at us. You don't know. And that's why we look at both of them, and they're kind of saying, hey, look, this one may be coming our direction. We'll have to wait and see what the models come up with. But then here's that other one. Now, people have asked me, why are they graying that out? Well, that's what the camera does, okay? The camera grays that out because it's really bright. It thinks it's like a real bright, I guess, flaw, anomaly in the camera. But it pops back on in the next image or two there, okay? See that? So, and you can kind of tell, even around the disk here, they keep that kind of gray because of the Coulter disk and the coronas here. It's not always like that, but, So if I keep going forward here, you're not going to see a whole lot because this model here has not been updating like it typically does. So there's one going off the backside. Oh, the right, yeah, there's that one there. Going this way, okay? And then there's another one, okay? So I do think that some of those could be coming at us. I can't say for 100%, but I do think that probably is. We'll wait and see. We'll see what the data when the data starts coming in. Yeah, don't freak out about that either. That's a calibration roll. I showed you guys that yesterday. Let me bring this over here. Man, this thing is like running slow. I do want to show you this. You got 1, 2, 3, like 9 sunspots right now. It's kind of crazy. But these are noctilucent clouds, guys. They happen in the summertime in each respective hemisphere. It's water vapor freezes around meteor dust. That's what that is. Okay, and it makes blue metallic looking clouds. Why do we talk about that? Well, first off, it's cool. Second, they just discovered these just a few years back, and it does help us understand if temperatures are off. Because if you get more glacier melt and stuff like that from higher temperatures, it creates more water vapor. So what it does is when it gets way up in there, way up in the atmosphere and the highest parts of our ionosphere, it will that water vapor will freeze around meteor dust. At least that's what we've been told. I don't know. I mean, I'm sure that's is what it is, right? I mean, you guys can decide what you want to believe on that. But, I have no reason to think anything is like crazy with that. I've never heard anybody really even talk about that a whole lot. But it does help us understand that if temperatures are changing and stuff like that. And that's a big, that's a big deal over there, especially like over in England right now. That's a big deal over there. That it's hot over there, guys. Hey, Miss Honeybee, good to see you. Julie, what's up? Good to see you. Hey, Virginia. John's in the house. Miss B's still here. Okay, cool. All right. Let's go down here and check out the 211. I like showing you guys this one because it does show the coronal holes really, really well. Okay? But it also shows like if there's like that solar tsunami yesterday. Okay? It shows those really well too. You can see the atmosphere kind of react and go a certain direction or whatever. But what you're going to see, I'm just going to let this roll. You can see this coronal hole. I mean, that's substantial. But check this out. You got another coronal hole. Now remember, there's something called the parallax effect. You guys know what that is? I've explained it before, but I haven't explained it in a while. Things that, when you're looking at a sphere from one direction, like from our perspective, things that are on the side will look smaller than what they actually are. And as they rotate closer and closer to right in front of you, they'll seem to look like they're getting bigger, which actually could be true, but it isn't always. So what I'm saying is, when we look at these things and they look really small over here, they may not be that small. It's the parallax effect. I know some people know what that is, and some people don't. Don't feel bad if you don't. Hey, Pamela, good to see you. But yeah, don't feel bad if you don't. I mean, that's like high school level science stuff that most people, we forget that stuff when we get out of school, right? Hey, Kenley, good to see you. Savage Dave, what's up? Good to see you too, Daniel. Good to see you, brother. Pamela, Miss Sunny. Okay, cool. All right, so what we got here? We got auroras. And again, guys, when we start getting hit with these geomagnetic storms, this thing is probably going to kick into high gear. You're probably going to see these auroras right here. You see how they kind of, let's bring it back this way. You see how it's kind of bordering the states here between Canada and the United States? You're probably going to see this stretch down to about here. Okay? So you're going to start seeing reports of aurora. If we get to like a G2 and G3 for any substantial amount of time, you're going to see it down here, like Colorado, obviously Montana, Idaho, the Dakotas, Minnesota, Oregon, Seattle. But it may even stretch down into like Northern California. If it's big enough, you're talking Nebraska, Iowa. They call this mid-latitude, okay? That's where most of us all live on the planet anyway, because it's the best climate. It's easier for us to live, right? But here's the southern lights, okay? Borealis, Australia, I think is what they call it. Hey, Russell, what's up, bud? So, yeah, there you go. But let's. I did want to show you too, for my friends down under. I haven't shown this model in a while, so let me show it to you. Okay. If I can find it. There it is. This is okay. We got this one, right? This is the magnetopause model that I show you guys all the time. Sun's on the left, going left to right. Right? That's where the way the energy's going. So, I'll tell you what, I'm going to just update that real quick. And you're starting to see stuff move. See those little waves starting to come in? So let me grab it right here. Right, you see that first one right there? Okay. There's another one. See it? Just bam, 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 bam. Now, see that coming in like that? So, yeah, we're starting to see the beginnings of this, okay? The geomagnetic storm isn't actually supposed to happen until, it's supposed to start here very, very shortly, here in the next few hours. Now, they give themselves a 7-hour cushion one way or the other. Now, when you start seeing the magnetic pressure do what this looks like right now, we're starting to take hits. When you see a bunch of different colors real close to each other lining up right here, you know that we're reacting. Okay, you can see us bouncing around. Just like this. Okay, so you heard me talk about vibrating real hard here on the magnetosphere. Well, I don't know why I haven't been showing you guys this one, because it's so much easier to show you what I mean on this particular model. This is the Australian version of a magnetopause model. This is our bow shock. That's what that line is. And you get all the same data. You get density. You got your BZ, looking for -6. Remember that. Then you got your solar wind speed. 350 to 500, or 3 to 500 kilometers a second is normal. So it's above or below that. That would be outside of what we would consider kind of normal range. But it doesn't actually mean that we're going to be having issues. But it does help us understand when stuff is coming. So let me push play here. Okay. Yeah, we're going to. So watch what this does. Okay, Earth's here, guys. And then, again, this is the satellite line. See how it's bouncing that bow shock back real close to the satellite line? When it does that, remember, our bow shock is where the solar wind, or CME, plasma, meets the beginning stages of our magnetic field. It's that first spot. Okay? So keep that in mind when you're looking at this, because when this thing starts bouncing and it gets like, we'll see it come inside this satellite line. What does that mean? That means that now our magnetic field has been compressed enough that the satellites are basically out there just getting smashed with solar wind. Because our magnetic field's protecting them right now. That's why they put them here, guys. You put them out here outside these magnetic connection line, and man, back at you, Jan. So, they won't last as long. I mean, there's been a lot of talk about the new James Webb telescope that's out there, and, they expect some dust to hit that thing, guys, okay? So don't think that that's anything out of the ordinary, but it does seem like they might, what they missed on, I think, from what I understand, is it actually got hit with bigger dust particles than what they expected. They always expect some, and it is out there. I mean, it's out there way outside any kind of magnetic protection. And the biggest hurdle they had was trying to keep the telescope cool. That's the biggest problem that they always had. And, so they kind of tried to figure that out. Now, I can't remember what the actual temperature is on one side of the satellite to the other, but they blocked the sun on the one side, so it keeps the. I mean, it's a big difference too. It's really, really cold where the telescope is, and they want that because it helps it see better. So anyway, I want to show you guys that because I haven't showed that. So shout out to my people from down under. Love my Australian family for sure. I ain't had a chance to say hi to Alan in a minute either. He lives in Australia. Yeah, man, I miss my people, man. I really do. Anyway, so as you got this, you got all these satellites here. So, yeah. So when we're talking about magnetic storms, that we do consider that. That's what we're paying attention to. Now, this is the geoelectric. Again, they've got this here basically to try to help them understand space weather's effect, how it affects earthquake activity. That's really what this is here for. USGS, you see that? But this helps us understand space weather on a better level anyway. This is showing you space weather's effect on our electrical grid or artificial electrical components. Thanks, Joanne. I appreciate you. I really do. Say hi to him for me if you would. Hey, Mark, what's up? Surgery, what's happening? But yeah, so you got this happening here. If anybody sees Chris from up in Canada, guys, tell him I said hi, okay? Please. Yeah. I miss people. That's all. Anyway, so we're gonna take a look at this one more time, and then I'm gonna pop off here because I've been on here longer than I thought I was gonna be, like I am every freaking time. Which is why I try to stream when my family and stuff is in bed and stuff. When I do try to come on here. How long I've been here? About a half hour. Okay, that's not too bad. That's the problem with my computer today, though. It's running really slow. But anyway, guys, here's that, and it's coming. Okay, it's going to be here. It's probably starting to impact us now. I think it's starting to. You can see even this latest reading here. It's starting to pick up. Okay, we're at a 3 on the KP. We get to 5. That's G1. My guess is when this thing hits, you're probably going to see it here, and it's probably going to jump straight up to a 5 or a 6. So that's what I would say. Hey, Adi. Hey, Ben. Cool. Oh, man. So, yeah, guys, anybody that likes Aurora, please go check it out. It's cool stuff. Hey, if you guys ever get those Aurora pictures and stuff and you guys want me to share them, send them to me. I'll post them. 100%, I'll post them. I'll give you credit for it, and we'll post them. Let's see here. What do you want to know there, Sister Gabriella? No one answering my question. Do we still have a crack in our shield? Okay, there is a lot of... I'm going to answer that question. I'm going to end the stream. It's not necessarily a crack, okay? And I know that everybody uses that word, including myself. I say, hey, we got a crack in our magnetic field. We say that because that's what most people will understand. It's easier and faster to say than it is to say this. Yeah, we got a thin spot in our magnetic field that might be opening up, getting ready to allow geomagnetic weather in. Space weather, plasma, all that stuff could be coming in through a hole that's getting smaller, thinner, or wider. Or we could say, hey, we got a crack in our magnetic field. We might be looking at some aurora. Do you see the difference? That's why we say it like that, because it's so much easier. It's not like a crack like on an eggshell, okay? It's more like a hole, right? Or a thin area in our magnetic field where there ain't so much, where it ain't as strong. And we see this a lot with the South Atlantic anomaly. I'm not going to get into that right now, but that's down in between South America and Africa. It's actually split into two now, and it's getting bigger. Magnetics in that area go crazy. They whack out. But yes, that was a great question, Pamela. So thank you for asking. I'm sorry if we missed it. I try to answer the questions when I see them, but tonight I tried to not even look at the chat a whole lot. And I think I did a pretty decent job with that tonight. I wasn't swirling around too much. I just try to stay more focused. You guys know yeah. Yeah. Some people are sensitive to it, guys. Said it hurts her. Guys, there's so much science that shows and proves that solar activity affects our health. Back at you, Russell. Back at you, bud. Love you, Hilly. Man, you always come in there with them one-liners, dude. I love that stuff. We've got a crack at our shield, Mr. Sulu. What we gonna do? Love the Star Trek. Love it. But yeah. So I'm going to go ahead and get off here, guys. I'm going to go in here and sit with my wife. We're going to watch some TV. Might even have to make her rub my back or something. I'm not sure yet. She looked at me when I said that. She's sitting like 5 feet from me. Well, my depth perception is a little off. I had the same problem. So anyway, we're not going to go down that line of thinking right now because we might end up in a gutter somewhere. So we're not going to do that. All right? Anyway, God bless. Yahusha saves. And guys, go check Mark out. He's live right now. He's got some guests over there. Go check him out, please. And anybody else here, guys, that, Rip and everybody else. I'm not going to, go through the whole list tonight, but please do. So, God bless. Yahusha saves, and I'm still blue Kool-Aid. And guess what? You guys can still drink it, right? I hope so. You can drink this Kool-Aid. Shalom. Shalom.